sort that out subsequently. So the main type of array formulas that you will see is something called a single cell array, which is when we're entering data into one cell on its own, which is similar to any type of formula that you've encountered so far. But the main thing that we'll be spending time on today is something called a multi-cell array, which is a little bit of a strange concept. So we'll look at quite a few examples there, but effectively it's a formula that you can enter at multiple cells at the same time. So it's not like creating one formula and then dragging it down, which is something that most of you are probably familiar with. But a multi-cell array is something that is a formula that displays its results in multiple cells at the same time. So that's a little bit of an abstract concept, which we'll spend a little bit more time on this discussing. So these are the main type of formulas that you see in Excel for array formulas. You can enter any one of these by pressing Control Shift and Enter. So that's the main part to enter array formulas. If you normally enter any formula, you just type in the formula, you type Enter, and that's it. But for array formulas, you need to type Control Shift and Enter at the same time. Only if you type those three keys at the same time, then the array formula will be entered. As a result, you get some curly brackets around the formula, and we'll see that later on as to what that actually looks like. But again, these curly brackets, they just appear by typing in Control Shift and Enter at the same time. It's not something that you have to add manually yourself. So sometimes people make the mistake and add these curly brackets themselves, but that's not going to be an array formula. In fact, that's just going to give you an error. So curly brackets appear once the computer has recognized that your array formula has been entered correctly. Then these appear automatically. There's a slide, especially if you can't see it, I'll talk you through it a little bit, but it's probably better just reading it after the webinar in detail, because it's a little bit more technical. But effectively, there's a bit of a point on efficiency in array formulas. So one of the key benefits of array formulas is not just to cut out intermediary steps, but it also does make certain formulas a little bit more efficient, which means you save a bit of calculation time. If you find that your spreadsheet is a little bit slow sometimes, and there are certain formulas that take quite a long time to calculate, then array formulas in certain instances can make that more efficient and therefore easier to calculate. But this doesn't always work. So it's not a sort of concept that where you can just learn array formulas, make everything more efficient. It very, very much depends on the situation. And there are actually quite a lot of situations where array formulas make your spreadsheet actually more complex and slow things down. So again, this slide goes into it in a little bit more detail, but if you want to know the exact sort of science behind how you can create efficiencies in your spreadsheet, whether you it very much depends on the situation. So for each situation, you would have to decide whether you want to use a normal formula or an array formula to do the job. There's usually always at least two possibilities. And again, in more advanced courses, you might learn the exact method behind it to determine which one would be more efficient. But at this stage, especially, if you're just getting introduced to array formulas, then the easiest thing is to just try out. If you have a formula that seems to take quite a long time to calculate, you can try out an array alternative and just basically see if that does solve your problem and it makes it more efficient. If it doesn't solve your problem, then you might need to try other alternatives. So at this point, it's easier to just try it out rather than trying to calculate anything up front. And like we mentioned, there's another concept which solves some of the problems that array formulas have. So as well as array formulas saving a lot of time, making things more efficient, making things easier to look at because there's a lot less intermediary steps. They do have certain problems, certain characteristics that people don't like about them. So there are ways, even though a lot of people think that really, really complex problems can only be solved with with array formulas, there are actually ways to come up with an alternative solution to almost any array formula, so that you can get more sort of standard formulas to do the same job as an array formula would do. But as a result, your formula itself will become huge and quite messy and quite hard to read as well. So there's a trade-off between doing that. Again, we'll just very, very briefly touch on that today because it's a massive topic and very complicated in itself. So we'll look at that quickly today, and then maybe come back to that in a more advanced course. Cool. We'll move on to the actual spreadsheet examples. So hopefully most of you guys can see the Excel formula on screen. So I've just got my Excel up at the moment. Hopefully it's not it's not obstructing the view too much for you, but whatever you had in front of you earlier. But I've just got the example spreadsheet in front of me at the moment. So the very first thing that we'll be looking at is the concept of multi-cell arrays. So that was what I said earlier. That was a little bit abstract and takes a little bit more time to get used to. What we've got on screen here is we've got some data going from very, very basic example data going from left to right. So you can see the numbers 1, 2, 3 going from left to right. And then we've got like a very basic array formula that takes that same data and transposes it down the way. So transposing just is a technical jargon term for meaning we're changing the layout of that data. So instead of making the data go horizontally from left to right, we're going to make the data go vertically down the way from top to bottom, which should give us the same problem. So what we've got here is something called it's called a vertical array function. It's the very technical term for it is called a one-dimensional vertical array, because what we're doing is we're taking that data and we're vertically making that go down the way. If you actually look into that formula, it says the function itself is called transpose, and it takes the data from B3 to D3 and it transposes it to go down the way. So it really just does that. It just changes the horizontal data to make it go down the way. And that's all it does. So it doesn't seem that technical, it doesn't seem that complicated, but this is one of the standard array functions that we've got, because what it effectively has to do compared to any other functions that you might have seen, only ever deals with one cell at a time. Even when we're dealing with range of cells, it only displays it in one cell at a time. If I want to build a sum function on all of this data, then the sum appears in just one single cell. If I want to add this data plus this data, or like subtract this number from this data, the number, then wherever I'm putting my formula in, it's only going to deal with these numbers, but then display the result in one single cell at a time. However, in this example, what we need to do is we need to take all of these numbers, then we need to display all of these numbers going down the way. So we can't just do that in one single cell, because if we there's 3 different data points, we effectively need 3 different cells to display that data in. So the formula, and this is what's a bit strange, the formula isn't just something that you do in one single cell and then you drag it down. The formula that is something that actually extends over 3 cells. So these 3 cells act completely together as one unit effectively. Like when you enter that formula, you don't just enter it in one cell, you enter it in the entire range of cells in one go. It's a formula that needs 3 cells to display the result in effectively. So that's what's called a multi-cell array. And you can see that from the moment you try and change that in any way, if you can see that any one of these cells contain the exact same formula. It's all the same formula. It's all linked to the same underlying method. If I try and change any one of these, so if I try and, for instance, click on the number 3 and click delete, then it comes up with an error message saying you can't change part of an array, because I can't delete just one of the cells without affecting the overall formula. The overall formula is in all of these cells combined. So if I want to delete them, for instance, I have to select all 3 of them and then delete it. Otherwise, it's not gonna let me do that, because the formula is in all 3 cells combined. Similarly, when I'm entering them, I can't just enter it in one single cell. What I have to do is I have to select all 3 cells that I want to display the result in, and then press the equal sign, type in transpose, select my data and close the brackets, and only then will it appear in all 3 cells, because I've highlighted them all to begin with before I've even entered the data. So if I do that, once again, if I just press enter, it's just going to be a normal standard formula. But if I want an array formula which lets me do this particular method, then I need to press Control Shift and enter at the same time. Only if I press Control Shift and enter at the same time, only then will it appear in all 3 cells exactly the way I want it. And you can see as a result, I'm getting these curly brackets around my formula, which is just an indication to you that the array formula has worked. And and is doing exactly what it should be doing. So these curly brackets, like I said earlier, it's not something you have to enter manually. It's something that happens automatically in Excel as and when you press Control Shift and Enter. That's when that comes up. So like I said, this is an example of a vertical one-dimensional array function, because it's given me all of this data vertically. Similarly, I could do a similar example going the opposite way. If I have some data going down the way, and I want to display them vertically, horizontally, sorry, then I need to highlight some cells horizontally from left to right, press the equal sign, and type in transpose, similar to what we did earlier. Highlight the data, close the brackets, and once again press Control Shift and Enter at the same time. And only if I do that will it once again transpose the data, but this time I'm transposing it horizontally. I'm going from left to right, so that my formula works. What you have to be careful with as well when you're using array functions is you have to know exactly how many results you're gonna get. So with three, if I want to transpose three numbers, then my array function is going to be across three different cells, because I need three cells to display that result. If I want to, start again, if I want to do, four functions, then obviously I will need 4 cells. I will need to highlight 4 cells before I start the function. Only then, will it work properly. So if I do a transpose function again, and make that go across 4 cells, then it should pick up all 4 cells. And make that work correctly. If you try and do more, if you try and display results than you actually have, so if you make the formula, for instance, go across 5 cells, even so you only have the data for 4 of them, then it'll give you an error message, because it simply runs out of results. So it can't display 5 numbers if it only has 4 to begin with. So hopefully that makes quite sense, quite a lot of sense. You can see here, if I do that, it's giving me the 4 numbers that I want, and then in addition to that, it gives me an A value, because the last value I'm saying, give me 4 numbers and then transpose them into 5 cells. That obviously doesn't make sense, so it's giving me an A error. So before you set up these multi-cell arrays, you need to decide already, how many cells do you need to highlight before you start writing that cell. The slightly more complicated method of entering these multi-cell arrays is something called a two-dimensional array. So that's when you get a matrix structure of different values. Then you can transpose, for instance, the entire thing. And again, this is just one simple example. There will be lots and lots of formulas that can deal with one-dimensional arrays in either direction, or two-dimensional arrays as well. But transpose is just hopefully one of the easiest ways to get introduced into that concept. So if I want to take this entire table and transpose it so that it's going into a different direction, then I would need to highlight the exact range of data that I would need as I'm printing out those results before I'm starting to type in the transpose function. So if I type in the transpose function, once again, highlight all of these data points, close the brackets, and press once again Control Shift and Enter at the same time. Only if I press something's gone wrong there. I'll do that again. If I type in all of these values, press Control Shift and Enter at the same time, only then will it let me transpose all of these values in a two-dimensional structure. So that's, the jargon term for that would be a two-dimensional multi-cell array. So that's what we've got here. So hopefully that makes it clear, at least on a basic level, as to what these array functions are. They are functions that can deal with a collection of data, and they, contrary to normal functions, they treat the entire data as one unit rather than as separate units. If you did something like this, where I'm saying repeat, like if I do a normal function and repeat whatever is in cell B17, then I'm only dealing with one result at a time. Even if I'm tracking that down, even if I'm repeating all of these words like numbers, it might seem like I'm doing something similar to the array example that we've had, but really every single time you're tracking that down, you're changing the formula. You're going from B17 to B18 to B19 to B20. So every single cell contains an entirely different formula. Whereas the array function contains the exact same formula. It deals with the entire data as one unit. So even so it gets a bit more technical, the efficiency point is that if you have, for instance, 10,000 lines of data, then Excel would have to 10,000 times, if you do a standard formula, 10,000 times have to change that formula, 10,000 times go into each cell, select exactly what's happening, copy that data over, print it somewhere else. Whereas an array function, rather than doing the same step individually 10,000 times, an array formula would sort of load all of the 10,000 values into the computer in one go, and then it would just print all of these 10,000 values out in one go as well. So instead of doing 10,000 steps, it would do 3 steps effectively. So it sounds a bit abstract, but that's already part of the reason why it might be more efficient in certain instances to do an array function instead of a normal function. So that's what we call a multi-cell array if it's displayed in multiple cells at a time. We also have something called a single cell array, which is a little bit more complex. Effectively, it can do maps to multiple ranges at the same time, and then print out as a result in a single cell rather than in multiple cells. And we can see a couple of examples on this second tab here. What this second tab shows you, and this is maybe one of the standard type of problems you've encountered before. What we've got here is we've got different types of items. So we've got different fruits: apple, banana, pear, orange, and so on. And we have a table that shows us how many times we sold each one of these fruits and what the price is for each one of these. So we've got the number sold, the price. And what we want to work out at the bottom is the total value of all of these figures combined. So what is the total revenue value effectively for all of these figures combined? So the standard way of doing that without an array function is we would need this last column here, which we've already pre-populated. You can see it's saying give me C3 times D3. So give me the value that you've got in cell C3 and multiply that with the value you've got in D3. And then we've tracked that down. So once again, it says C3 times D3 in the first cell, C4 times D4 in the second cell, C5 times D5, and so on. So this is one of the key sort of basic intermediary steps that people sometimes need in their spreadsheet. So what we've got is the number sold, the price, and what we want is the total revenue. We don't actually want these individual revenues. The only reason we've calculated these revenues is that at the end we can have a final sum function which says give me the sum of E3 times and E7, meaning go all the way down the list of all the individual revenues that I've calculated and then add all of them together. So the only reason we need this intermediary step is so that we actually arrive at a final step in the end. It's a very basic example, but it's the kind of thing that people do all the time. Even so, they don't need to see this individual revenue column. They need to have it as something called a helper column, an intermediary step that gets you to the final result. Now, again, this is a basic example, but you might have similar problems. But instead of just one helper column, you might have 2 or 3, or even I've seen places which have 20, 21 different intermediary steps just to get from the initial data to the final result. Even so, nobody wants to really see these intermediary steps. They're only there to get you to a point where you can calculate the final result, which is quite an inefficient thing to do. It looks quite ugly in your spreadsheet as well. If you instead of going from A to B, you have to go from A to K to M to L to O and eventually back to B. It seems quite an indirect way of doing things. What people sometimes do is they then sort of hide these intermediary steps or put them on a different worksheet so that people looking at it don't have to see these, and so on and so forth. So these are all workarounds that we have to do when we're using these standard functions. But again, the key benefit of using an array function is that we could do all of this in one go and just use all of the ranges of values that we see and just calculate the entire thing in one single formula without needing these intermediary steps. And this is exactly what we've done in this second example. So what you see in this second example, and the key thing to understand as well is that array functions are sort of nothing usually special compared to normal functions. So any normal function can become an array function the moment you press Control Shift Enter. So you don't have to learn, if you've learned 20, 30 functions in Excel, you don't then have to learn another 30 array functions which do something different. A lot of the functions in Excel can just be made to be an array function. So you're switching on some additional functionality effectively by just pressing Control Shift Enter, getting these curly brackets around it. So the standard function, sum function that you've seen so far, like in this first example, really just adds numbers together and that's it. But if you type the same sort of sum function into an Excel spreadsheet and press Control Shift and Enter, then it becomes effectively a sum array function, which can do more complex stuff. Like we see in this example, we can do the entire intermediary step that we had to use a whole extra column for earlier in one go. So what this is effectively saying, it's saying multiply the entire range of data, C3 to C7, multiply the entire range of data that we see here with the entire range of data D3 to D7. And what that is doing within the cell is within the same function, it's saying C3 times D3, C4 times D4, C5 times D5, and so on and so forth, until we get to the very end. And after it's done all of that, then the sum function adds all of these values together, and only and it effectively does exactly what we had to do with intermediary steps to the left hand side. So it won't work if you try this with a normal function. If you try and do the sum function and just print it out like we've done it here and just press enter, it won't work. But if you switch on this additional functionality and press Control Shift and enter at the same time, so if you make this an array function, then it should work, and it should give you the result that you see on the screen. So you can see here both of these functions will work exactly the same way. They'll both give you the same result, but again, the key difference is one of them will use a helper column, the other one won't, meaning that if I delete some of these additional entries, then my first function will stop working. It will just say 0 because it's needing this helper column. So my second function will still work. It will still do the exact same thing. So it's more efficient. It needs less data. It's less ugly because it doesn't have this intermediary step, and it's less risky to a degree as well, because it means that you don't have the problem that potentially like a certain colleague or client accidentally deletes one of these cells, one of the helper columns. The less data you have in your spreadsheet, effectively, the less potential there is for things to go wrong. So that those are the advantages of an array function. But what you can see in this example is everything, the entire result is in one single cell. So that's why it's called a single cell array function, as opposed to the one we saw earlier, which is got its results in various cells. So that's why it was called a multi-cell, like a multi-cell array function earlier. The final thing that we see here is something called a de-arrayed function. And again, it's just a very, very quick introduction to the topic so that you have seen that before. Like we've seen earlier, you have to press Control Shift Enter to enter these values, which a lot of people forget. So as good as array functions are, the moment you want to modify that or change anything about it, the moment you press Enter instead of Control Shift Enter, which is a very easy thing to forget, then the whole function doesn't work properly or stops working altogether, which is quite a big risk and quite annoying as well. It's another thing is that array functions are probably the least understood type of features in Excel spreadsheets. So while you might be really good at it, your colleagues might never have heard of this before. So like a lot of companies don't like these because they're just too technical for people to understand. Also, these curly brackets around it, again, people sometimes accidentally do them manually rather than pressing Control Shift Enter. So there's quite a lot of sort of features that if you don't have the knowledge about how these array functions work, people get them wrong. So there's a lot of companies that don't want these type of functions in there, or even have policies against array functions altogether, because they don't like the amount of errors and risks that causes for people who haven't understood the concept very well. And just because it's such a difficult and abstract concept, people shy away from these a little bit. So what you are able to do in Excel, although it gets quite technical, is in theory there should be an alternative way of doing the exact same thing that we've done for every single array function out there. But you almost have to learn array functions to be able to do a process that is called de-arraying functions, which means using the same sort of methodology, using the same concept, but doing that without pressing Control Shift Enter and effectively getting the same result without entering an array function. One of them you can see here, and again, this is just a very, very basic example, but when it gets a little bit more technical than that, then these functions become extremely complex. But it's the kind of thing that certain companies sometimes want. I've been to certain teams where they've asked me to take all of the array functions and make them normal functions, just because certain people have misunderstood them and deleted the wrong things, and that kind of a thing. But it effectively then becomes a little bit more complex. One of the examples that you see here is something called a sum product function. A sum product function is one of the most advanced functions in Excel because it can handle multiple calculations within ranges at the same time without having to be an array function. So a sum product function is effectively something that's got an array function implied in its own function. So this is a function where you can just press enter and it's going to do something similar than compared to the sum array function that we saw earlier. So you can see here we've done the same thing, C3 to C7 times D3 to D7, which wouldn't work if I just typed in sum without the product part. Then that wouldn't work. The fact that I've typed sum product and made it a more advanced function, something called an de-arrayed function, then the whole thing will work even if I just press enter. The sum function, if I just press enter here, then you can see it doesn't work. If I just try and do this to a normal sum function, it doesn't work because it doesn't understand the concept of multiplying ranges with each. I have to press Control Shift and Enter for that. For that to work, to turn my some function into an array function. So effectively, if you can rearrange your problem to fit it inside a sum product function, then you can make almost any array function like a normal function, if you like. The index function, if you've come across the index function before, then the index function is another very technical, advanced function that has the same sort of feature. So you can rearrange a problem to put that inside a sum product function, or to put that inside an indirect an index function. Sorry, that can effectively de-array any function and then turn that into a normal function. There's a couple of other functions that will have the same methodology, but the problem is then that you need to know exactly what a sum product function does and what an index function does, and you need to find some sort of a solution where the logic that you want to express can be put inside of a sum product or inside of an index function or any of these alternatives, which is extremely difficult, but it is possible to do that. So if you just get into it, then it's better to just use normal array functions. If you want to then take it to the next level, de-arraying functions would be the next thing that you could learn from here. So let's just look at a couple of examples just to make it a little bit easier to understand, what type of problems you can deal with array functions. But once again, these are just introduction examples today. That there's no limit to how complex you can make this if you use it wisely. But what we've got here, just to give you a couple of examples that we can do directly with an array function, is we've got different numbers here, and we've a list of different numbers, and some of these data points that you see here on the screen have got errors in it. So we've got the value error, we've got the NA error, we've got the division by zero error, and then we've got different values at the same time. So you might have got similar examples where for whatever reason certain parts of your data are incorrect and give you an error. So there may be situations where you want to then just add all of these numbers together, for instance, and just ignore those errors. So maybe you want to add 25 plus 2 plus 51 plus 23, and basically just ignore those errors. Or maybe you want to take an average of these or count them, or basically do anything with the valid data. And whenever you get an error, you just want to ignore that type of data. The problem is if you do any function on these type of on this type of data. So if I do normal sum function, press enter, you can see it's giving me an error because any function that contains errors, if I do a count function, any function where the data contains errors will give you an error unless you have very specific type of functions like this one that I've done here, which will ignore errors implicitly. Certain ones can deal with that directly. Certain ones can't, like the sum function and the average function. So there's a couple of functions that can deal with this, but other ones can't. So other ones, if they hit any sort of error, they will just give you an error subsequently. So if you wanted to simulate something like that, again, what a lot of people would do is they would use, first of all, some way to manipulate this data to give you like a list of data points without the error. So for instance, one of the functions that you might have come across is the if error function. So a lot of people would use the if error function and say, if you see an error to the left-hand side, then just print out the value 0, for instance. And if I print out the value 0, then it's effectively like ignoring that value, because I'm just gonna, if I add 0 to any sum, then I'm not gonna affect the final result. So a lot of people will do this. They will do a helper column. Once again, a helper column that just cleans up my data. So when it's the same value, it's gonna give me the same value. When it's an error, it's gonna give me 0. And then after they've done that, then they can use, for instance, the sum function, which function, or any of these, and use the cleaned up value to then give me the final result. So once again, this is a standard way of where you need some helper column, some indirect method of arriving at the final result. Even so, we want to go straight from A to B, we need to go to a second set of data which deals with my original data, and then only then can I give us the final result. But once again, if you use array functions, then you can do the entire thing that we've just done in one single step. So you can say, instead of doing an if-ever function for each individual cell, you can say, give me an if-ever function of the entire range of cells already. And then once you've dealt with the entire range of cells, then inside that function, so if I evaluate just this part, then what's going to happen is, inside that function, Excel is going to evaluate the entire range. It's going to say, similar to what we've done earlier, 25 for the first one, 0 for the second one, because it's got a value error, 2 for the third one, 51, and so on and so forth, until it gets to the very end. And once it's done that first step, then it's taking a sum of all of these values, which will then give you the same result one as we had earlier. So it's just a way of dealing with the entire thing in one go. And again, once again, we're only saving one intermediary step here, but it's just for illustration purposes, because it's an introduction webinar. As you get more advanced, you should be able to do 2, 3, 4, 5 steps in just one go, using these type of functions. Similarly, here we've got a second example where we've got positive and negative values. So you might see this in certain businesses or in certain processes where people want to check have some sort of a control mechanism, and find out what is the deviation from the value that I'm expecting. So maybe you've got a machine and it's producing a certain amount of units every day, and you want to you expect it to produce 20 units every day, and you're monitoring whether that is actually the case. So maybe one day it's producing 24, so it's produced 4 additional ones. Then the next day it's producing 25, so it's produced 5 additional ones. Then the day after that it's producing only 14, so it's produced 6 less than you expect. So you want to monitor all the deviations, and then find out how efficient is that particular machine, how why is that doing it, is it doing it that way, like what's the reason for all of these the deficiencies effectively. So if you've got data such as this, again, one of the standard examples that we come across is people then want to find out the average deviation. For instance, how badly is that machine performing on average. So you don't really care whether the machine has made 4 units too much or 4 units too less. It's still wrong by the same amount, if you like. So even if whether it's produced 16 or 24, it's not produced as you expected it. It's deviated by four items, and the worse that gets, the more you want to monitor that. So in this case, instead of just monitoring the average of all of these deviations, so the average, if I just typed in the average like that, then what that would do is it would calculate negative values and positive values combined. So it would say that on average we're only deviating 0.8 units from the average, which is a little bit misleading, because actually you can see the example is much worse. If you're treating these negative values as absolute values effectively, then it's effectively a much worse case. The machine isn't really working correctly. So what we really want to do is we want to take these values and make them absolute. So when it says -6, we want to make it 6. When it says -3, we want to make it 3, and so on and so forth. So it's the absolute values that we want to deal with. So once again, a lot of people, what they will do is they will again make a helper cell or helper column and use the abs function. The abs function makes any value absolute and track that down. So you can see when the value is already positive, it makes it positive. When the value is negative, it makes it positive anyway. And then after they've done that, then they would use an average function on the helper column that they've created. So they would use the average function on this helper column, which gives me the value 4.4. But once again, just to finish this topic, if you use an array function, so if you do the same thing in just one single cell, so you say, give me the absolute value of all of these values, and then give me the average value after you've received all of these absolute values. Again, this won't work if I just type in enter. It's a bad example here. If I take that somewhere down here, if I just type in enter, it's not gonna work. But if you type in Control Shift and enter, then it's going to give you the correct result, because it's an array function which can handle with ranges of data at the same time. So hopefully that gives you at least a little. It's a very, very abstract and technical concept, but hopefully it gives you at least a bit of an introduction of how these type of formulas work. And if you want to see more of that, we can potentially do some future webinars for you specifically, or online like we've done today. Apologies for some of the issues you guys have seen on the screen. We'll try and figure out what happened, because that shouldn't really be the case, but I can't really see the gray screen on my end, so we need to do some testing on our end. But hopefully you could see most of what was happening on the screen anyway. And like I say, there will be a video that you will receive after today's course, so you can always go through that and stop it again subsequently. I'll just try and answer a few of the questions that came up at the end. But again, if I didn't get to your answer, we'll send you an email at the end. So thanks very much for your attention. It's been a pleasure teaching you guys, and I'll just mute myself and then answer some of these questions that have come up.